Good afternoon, everyone. Ever wondered whether you can get 100% in a physical examination at the end of the year? Well, let me give you some interesting numbers. Last year, if you watch at my screen quickly, you will notice that one wonders whether you can get 100%. Last year, 2,334 learners got between 90% and 100% in the final examinations. So how does one do it? Simple. Work hard, work every day. Physical science is more skill than just content knowledge. They are basic laws, but it's a skill, which means you have to practice it every day for about an hour to 2 hours long, along with mathematics, of course, because mathematics is our language, which helps us to solve the problems in specifically physical sciences. So what are we going to do today? Let's have a look. Today we're going to say we're going to have a look at Newton's second law and then focus on the motion of connected bodies. And I will ask you, and if we have time, we'll look at one or two definitions in the physical property and structure relationships in organic chemistry. So that's our plan. But what do you have to do? Very simple, all of you. I see a lot of names, and our learners are still sending some messages about the mathematics. But we can't answer that, but do please send in. And here's our contact details, as you see on the screen. You can either use the website, or you can use the WhatsApp number there it is for you, or send us an SMS, and we will then try to answer your questions as fast as possible. And don't forget to go to our Telematics School Project website on Facebook and click like and get active, but more importantly, get involved. Okay, so without further ado, let's get into the first question for the day. I hope you have your workbooks in front of you. The question is, which one of the following physical quantities, that means mass, energy, velocity, and acceleration, which one of them is a measure of inertia of a body? Now, you might ask, what is inertia? Or what is inertia, as some people call it? Well, let's quickly look and find out. Inertia is nothing else, but if the body is at rest, it will resist to change that state of rest. Or body is in motion, it will resist to change that state of motion that it is in. So which one of these four do you think is the correct answer? Well, let me give you two tips to give you a clue. The first is, you got to know your content in your laws, and especially your grade 11 work for today. Know your content. I will refer to it as we go along. And also know that in your grade 11 examination guidelines on page 8, we tell you that mass gives an object its inertia. Mass is causing the resistance of an object to any change in state of motion that it is presently in. So what is the correct answer then? Of course, the answer would be A, and thereby you scored 2 marks. So what's the lesson to be learned? If you did not read through your examination guidelines, all the facts are there, all the things that you're going to be tested on is there in an email, so to speak, from the examiner to you. So please go and study your content. They make up about 10% of your question paper, roughly, and you can get up to 22 marks on the level 1 questions, your definitions, and of course your free body diagrams, which we're going to look at today. But let's go to 2.2 and let's see what we have there. 2.2 gives us a scenario. As always, it changes in physical sciences. It says 2 blocks of masses 20 kilogram and 5 kilogram respectively are connected by a light string P. So this is a string. They are connected by P, and there's another string Q running over the pulley. And remember what the function of a pulley is? It is simply to change the direction of the force that we see here. Here we see a force, and this force is 100 or 250 newtons. That is how strong that force is. And they say a second light string Q, which is obviously attached to the 5 kilogram block, runs over a light frictionless pulley. That is what we're saying. And the question that you, of course, have to wonder about is, why would they tell me that this string is or the pulley is a frictionless one? Of course, it's not to cause any friction, which would be another force, which would then be in this direction. And they say, ignore the effects of air friction. So you don't have to worry about that. So that means if I study this diagram carefully before I do anything, I will then notice that this one is jerking onto this one, dragging on this one down, and this one, of course, the 5 kilogram, is pulling up the 20 kilograms. So we have tension 1 in this string. And please know your definition of tension. And we have another tension here, upwards and downwards. This one is pulling down, or these two are pulling down, and this one is pulling upwards. So we have tension is defined as a force in a string, like that. So we have 250, so this is also T2 is also 250 newtons. So that is a nice way to start the afternoon. And you always have to remember, analyze your diagram, because in physical sciences, it's a good thing if you have the word sum at the top. You don't follow, try to analyze, or try to make up a diagram for yourself that you will understand and remember all the important points. And now comes the first question, if we go to that one. Well, if we are clever physics learners and we know that this is all about forces, I can see there's tension, then I have to put in the forces that I already know about. And I know that the Earth is always pulling on any other body or object with a force called its weight, or some of you call it the gravitational force. But if that one has a weight downwards towards the center of the Earth, then surely the 20 kilogram one must also have a force. So there are two hidden forces that they did not tell me about. And now for the first part of the question. We have to state here quickly what is Newton's second law of motion, and we have to state that in words. Now, I have a tip for you, which I think that learners have to take note of, and I'll make use of it throughout this presentation. The first is, please learn your definitions as far as possible from the formula or the equations that are given. So the answer to this question is on my data sheet. That's where it is. Let's quickly have a look down on this scale, on this whiteboard in front of me, and you will see there is my data sheet. I'm going to shift it a little bit this way because I want you to see something. Can you see there in the middle of it now? Yes, there is Newton's second law. And it says F net is equal to ma. And of course, that's momentum over there, etc., etc. And there is my weight, which is equal to the mass multiplied by the gravitational acceleration. And there's Newton's law of universal gravitation, etc., etc. So please, this is a sheet which you must work from every day and learn your definitions from it. There are about 20 definitions you can just get on this data sheet. So let's show you how I'm going to use it now quickly by pointing out two features. The one is, so this is Newton's second law in terms of a formula, an equation. And of course, F net means nothing else. F net means the sum of the forces. So whenever you see net, F net, whatever it is, W net, as you're busy with now probably, just remember it means the sum of the force in this case, or the sum of the work, whatever the situation might be. So how do we use the data sheet to get to this answer? So what do we have to do? We have to answer this question, Newton's second law of motion. And we can do it slowly and say that when a net force acts on an object, then what is the left? The object will accelerate in the direction of the net force. And thereafter, that's our introductory statement, we start talking about the acceleration. So Newton's second law, if I get your attention, is nothing else but about acceleration. The relationship between acceleration and the net force, and then the relationship between the acceleration and the mass. Let's just look at the screen again one more time before we get to wording. So Newton's second law, I'm trying to say, is nothing else about the relationship between acceleration and the net force, or the sum of the forces, and the acceleration and the mass of a body. And that way it is directly proportional, and this way it is inversely proportional. Just watch what happens to the screen now, because I want to bring home another point. Notice I am making use of a flashcard to give you that answer, and that is something I want you to learn today. What am I trying to say? On the screen you will see that when a resultant, or another word for resultant, a net force acts on an object, the object will accelerate in the direction of the force. And this acceleration, that is the main point. And notice this is where we normally get our marks. This acceleration is directly proportional to the force and inversely, not indirectly please, inversely proportional to the mass of the object. Notice this acceleration. So you make an introductory statement where you say when a body will accelerate, and thereafter you do nothing else but to talk about the acceleration, and you normally score your 1 mark there and your other mark there, and that's why you normally get 2 marks for such a definition. So, can I make a suggestion to you? The first is that you use the formula on your data sheet if you tend to forget something, and practice that starting today, please, not tomorrow, today. Let's quickly look at the whiteboard. Let me show you something. Here you see a way of quickly learning it on a daily basis. You make yourself a flashcard like this, writing the name of the law on the one side, and then on the reverse side, you put your details. And you carry this with yourself or in your pocket every day, and you learn it. For instance, I have asked some learners that they do it for me, and what did they do? Some just wrote up today, and this is what they do. A set of papers like this, and they would have the name on the one side, and Doppler effect, and the work energy theorem, etc. They would have there all the time in their pockets. And we always say we have little time in matric, but every minute counts. And when you carry that in your pocket, you can, of course, learn it quickly. And when you are bored, or let's forbid, don't sit in the classroom and say the teacher is boring and now you're going to learn that in class. No, outside of the classroom, in your transport mode, on your commuting, on your way home, or wherever you're going, take it out and make time to learn your definitions. Now already they count up to 22 marks. Last year there were 8 definitions in the physical science paper, and of course there were 6 marks for free body diagrams, and that gave a total of around about 24 to 26 marks. So you can get 100%. Remember I asked you earlier. Now the next question is, once we've answered that, what is it that we need to know for next? Very well, because up to last year, the NSC report on examinations had this one complaint. Learners do not know how to draw free body diagrams. Let's talk about it today. Here we go. Free body diagrams. What is it? Well, it's a diagram that shows magnitude and directions of forces acting on an object. That's what it is. So let's look at the detail of it and make sure that you never, ever lose marks 1 minute. But let me just quickly, before I go there, let me just quickly read what is on our screen. It's someone wrote to me and said, when a net force is applied to an object of mass, it accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. Unfortunately, there's no name. Otherwise, I could have told this learner, I hope, say it's very good. And someone else, I think Nyameko, who sent me, oh no, there's Anise Bonga, and someone else sent me a message and say it was the mass the answer, and someone else is saying good afternoon, and someone says I'm from Sipamantla Secondary School. Well, good afternoon to you and everybody else. And one more person says, can't wait for physical sciences, and we are ready. Well, Hanise, I think, Hanise Bonga, and someone else who sent in nameless answers. Please add your name to your answer so at least I can see whom I'm talking to. What were we busy with? Oh yes, free body diagrams. Do you know how many marks it counted last year? That's the 2017 paper. 6 marks. 6 marks for drawing lines. Imagine that. Now, ensure that you can do it. We're going to talk about it just for 2 minutes. Look at this quickly at my screen. 1. When you draw a free body diagram, what's important to remember, and how can you possibly lose marks if you are not that careful? That's the important thing to remember. 1. Once you've drawn the free body, you must show the vectors like force or displacement or velocity in times by means of an arrow. And what's important about this are the following. The head shows direction. That arrowhead there must not be lost, because T1 is upwards, that's the direction for that one, and of course for W is downwards, that's the weight or the gravitational force that we have there. Everybody get it? And then, next important thing is, we must show the approximate size. In other words, the tension is slightly greater than the weight in this instance. That's why it was accelerating upwards. So I think you can see the net force is upwards. Another thing you need to remember is the object is shown as a dot, not just taking your pen and doing this, please. Don't do the following, what I'm doing here on the, don't do this, no. Draw it like that so that one can see there it is. Make it a dot. And then from there, you make up your forces, especially because that's normally where you get these free body diagrams. What's important about this dot is, and the vectors or the arrows, is the following. The tails must all touch the dot. I'm coming back to that now and show you that you can actually lose marks. And lastly, we normally use W, a small w, for the symbol for weight instead of Fg for gravitational force. So please do that, and 2 things more. So remember, that is gravitational force, a small g, but because we sometimes leave out the g, or we sometimes make it too big, we prefer you to use the small w. Now, can you lose marks on these? Yes, so many learners have lost in the past. Here we go. If you have no arrowheads, you lose a mark. And if your tails of your arrow does not touch the dot there, you also lose a mark. And please remember, you can at times also lose marks if you don't show the relative sizes. What I mean by that? This one is bigger than that one there, for instance. You are more or less, you don't always have to be very, very accurate. Right, if you got that, last year's paper, 6 marks for drawing simple dots and arrows, touching arrowheads directly. Please always practice the one on an inclined plane, a slope, and practice one on a horizontal or a vertical direction plane like we did now. Will you do that? So ensure that you get all the 6 marks at the end of the year. Now, if we now talking about free body diagrams, then surely the next question is asking us to draw a labeled free body diagram indicating all the forces acting on the 5 kilogram block. Well, you're going to tell me, well, that's very simple. That shouldn't be too difficult. So let's go. I see if I do the first one. What is my first duty? Because I'm working with forces which are vectors, I have to indicate which vectors are going to be positive. That's the first thing I always do in a physical science question, except for work energy and some other place in your paper. So let's draw this one for the 5 kilogram block. So I'm going to draw this one first. So let's see, 5 kilogram block, there's tension upwards, there's tension downwards, and of course, there's the invisible weights that I have to add to it. So how many forces will there be? 1, 2, and the invisible one. Remember, that one has a weight, and this one has a weight because the Earth has a pulling force, a pulling power on it. So what would that look like? There we go. Now, I just need to connect this, the importance, the usefulness of a free body diagram to Newton's second law. And now you better listen very, very carefully, because this is the point, the transition phase from free body diagram, something physical, to applying it to a formula. This is where learners fall short sometimes, unnecessarily. And you know this is going to be question number 2, hopefully, in your paper, and therefore you must be prepared for it. So take careful note, draw with me, and watch what I'm doing today, because I'm trying to show you the skill in a very, very easy way. Let's have a look at my screen again. So now I'm going to write down Newton's second law in terms of the acceleration that we've spoken about earlier. And here we go. So we say F net, when a net force acts on an object, the object will accelerate in direction of the force, and the acceleration is directly proportional to the net force and inversely proportional to the mass. You get that? So there is it. Now, a second clue I want to give you, or I want to tell you, is this net force, sum of the forces, is the sum of T2 plus the sum of Fg, or W for weight, and this plus the sum of T1. F net, therefore, means the sum of 1, 2, 3. But I need to remember they are vectors, so that if I choose that as positive, then these two will be negative. If I choose that as negative, then these two will be positive. Got that? So F net, therefore, refers to the sum of these 3 forces here. Okay, you think that got that? That is where learners sometimes have a problem when they try to do this one. Unnecessarily use mark, and it's so easy. Let's look at that idea again, one more time, by drawing the other free body diagram. They did not ask for this one, for the 20 kilogram one, but let's do it just to show you how you got to think in the examination. So I'm going to do the one for the 20 kilogram block. I'm just going to let this disappear quickly for me, and there I go. So there's the one. It is the weight or the gravitational force downwards, the unseen one, and then T1, that's upwards, is that one there. You got it? So I'm actually taking one block at a time, one body at a time, and I'm doing it. So there's that one. So now I write down Newton 2 again, and I write F net is equal to ma. And what does F net mean again? Come, all you clever ones. I see there are learners who are sending me some answers. Before I go on, can I just quickly talk to one or two of you? Sun Deesware High School. I can't see where that is exactly, but I only see a small portion of it. And someone says, I'm enjoying the show. And Joshua from Kwezi Rom. So it's all I can see on my screen. And Newton's second law, someone says, and then many people have sent me the answers. Many people have sent me answers like A was the answer. Someone that sent 2 smiles, and someone says good afternoon, someone else says hello. As I will open those dots quickly to see the full comments that you made, but please keep on sending the answers. But where were we now, so before you interrupted me? Oh yes, we were talking about the importance of the free body diagram, their usefulness in solving Newton 2, and I'm busy doing the 20 kilogram block. Let's look at it again. So I'm writing Newton 2 there, and I say F net is equal to ma, but what does F net means? I know the m stands for the body, the mass of it, and the acceleration, which is the change in velocity, or the rate of change in velocity, and then F net is the sum of the forces. How many forces do I have here? 2. That means I must have the sum of the forces in this case, so I will take note of those 2 forces when I'm busy doing it. Okay, everybody, so what can I now write? Let us take this one step further. This was the question there. That was the answer for 3 marks. 1 mark if you got the magnitude and the direction. 1 mark for magnitude and direction. 1 mark for magnitude and direction. And they must all touch, otherwise it is -1. Remember. Okay, so let us quickly and let's do this. Which forces do I have to write here? There we go. I first mark upwards as positive here. I said at the beginning. And all downwards is negative. So therefore, I ensure that I take the direction into account when I work with vectors, like forces, for instance. So how many forces will I have here? 3, right. So there's T2, which is the positive one upwards. I do a vector addition plus minus T1, T1 is in downwards, and minus Fg. Okay, if I do that further, what do I find? It becomes T2 minus direction minus mg, because mg is the way I find weight, or equal to the gravitational force. I have 1, 2, 3. The sum of the forces is equal. Why did I write 5? Oh yes, 5 is the mass of this block here, and a is the unknown acceleration. Can I do likewise on the other side? Okay, we can. Let's quickly see what happens here. How many forces do I have? 1, 2. So I must have 2 forces. One is positive and one is negative. So I will have T1 minus Fg is equal to 20. Oh yes, because this is a 20 kilogram block I'm working with now. If I simplify that, it's T1 positive direction and minus mg. Mg is the way I calculate the weight or the gravitational force of the Earth. I calculated m times g, and that is equal to 20a. Do you think that's easy enough to understand? So what is the important thing I've told you so far? That you need to remember that F net is the sum of the forces, but I must keep my direction either positive or negative in mind. Negative and positive, simple in physics, means direction. So where are we next? Oh, here's the calculation that we really have to watch out for and that you really have to do today. So please pay attention now. Let's go. Let me remind you, F net is the sum of the forces. How many forces? 3, 1, 2, 3 is equal to, I just follow that, is equal to m is 5 and a is a. Right, so there we have that one ever ready. So let's look at the next question. Question 2.2.3. Question 2.2.3. I wonder what is it that they really want me to do in this question. Let's see quickly. If I go and I rewrite what I had so far, let us just see whether we can solve for t. So let's quickly see that this is our tools that we have to use. We have the correct formula from the data sheet, nowhere else. F net is equal to ma. This is my useful diagram that I'm going to use to write there. And I'm going to replace the 5 there and then a. And when I do the other one for the 20 kilogram on this side, I'm going to use these two forces as F net and 20 there and a there. So let's try and then solve for, we know what T1 is. No, we know what T2 is. We need to solve for T1. Okay, so we know T2 is 250 and we have to solve for T1. So let's go through it, and then I'm going to ask you to do it with me afterwards. Here we go. 1. We now know that T2 positive minus T1 minus mass times gravitational acceleration is equal to 5a. We know that, and I mark that as equation 1. Next step. Let us elaborate a little bit on this side. So T1 on that side minus m times g, and this time m will be 20, g will be 9,8, is equal to 20 times a. So what have I just done? I've taken the 5 kilogram and I made up an equation, Newton's second law equation for it. So this is F net is equal to 5a for that 5 kilogram. And this side, I've taken F net, which consists of two forces, is equal to 20a. Okay, so this is really what I've done. I've taken the two bodies, the 5 and the 21, which were connected, and I separated them, and I did a Newton 2 for the one and a Newton 2 for the other one separately. That is what I've done. I have isolated the one body, and I've isolated the other one, and I've applied Newton 2. F net is equal to m for this one, and F net is equal to ma for the other one. That is what I should have said. Right, let's continue it, and then afterwards you're going to do it for me. Right, so let us put some numbers in. Remember, formula first, formula from the data sheet, then substitute. Now we come to the substitution. What is the value of T2? T2, let's go to our diagram. T2 is the same as around the pulley, it's 250. Right, so we put that. T2 is 250 newtons. T1 is the unknown we must solve for. M we have on this side as 5 kilograms, and GV, gravitational acceleration, is 9,8, and that is equal to 5A. Well. We do the same on this side. We don't know what T1 is, but we can put in the others. Perhaps we can even simplify this like that and say that is 250 minus T1. I deliberately put in red because that is an unknown. Minus 5 times 9,8 is 49, is equal to 5A. So I put the one unknown in red and the other unknown in red, and that is my equation number 3. But maybe I must do the same on the other side. Let's do the same. So T1 is unknown. The mass of this one is 20. Multiply that by 9,8, it's 28. So there's my equation number 4. So I have an equation number 3 with 2 unknowns. I have an equation number 4 with 1 unknown. So I have 2 equations, and we call this a simultaneous equation. We always get this in Newton too. So what am I going to do now? I'm just going to simplify that quickly. That's right. So T1 is the unknown. 20 multiplied by that gives me 196 and 28. And now I have 2 equations with 2 unknowns. And now I know that's exactly what I need. When I have 1 equation, I can only have 1 unknown. 2 equations, 2 unknowns. 3 equations, if I have 3 unknowns, I solve it that way. So your aim must always be to take the one body isolated, get 2 unknowns, take the other body isolated separately, that I mean by isolation, and then you will see that you only 2 unknowns will be T and A. And now you must solve it simultaneously. And how do we do it? By eliminating one of the unknowns. Let's have a look by what I mean and see how we do this one. Okay, so 2 equations. So I'm going to write this one underneath here, and then I'll talk you through it, and then we're going to do it together. So I'm going to eliminate T1. So in other words, I'm going to try and get rid of that T1 and that T1 so that I can solve for A. So let's do it. Let's take this and rewrite it on this side. So I'm going to write that one on this side now. And there I have T1 minus 196 is equal to 28. You get the idea? So how do I eliminate T now? If I study it carefully, that is a minus T, and this is a plus T. How can I eliminate? Of course, by adding these equations together, equation 3 plus equation 4, if I add them together, I will get 250 T minus T and plus T will give me 0, so T will disappear. Then 49 and 196, it's minus 49 minus 196 is equal to 25A. And there I only have 1 unknown. Whoa, how clever am I? I just got rid of T1 just like that. Now, you will notice that I put in a lot of steps so that you can clearly understand what I'm doing, because I want you to do it on your own right now with me again, because I believe the more you practice and the more you see it and the more you do it yourself. Not when your teacher are doing it on the board, you must do the homework. You need to practice it because you are going to do it in the final examination. Can you see how important it is working and not copying? I'm talking about that mathematics and physics homework that you copy so now and then. Everybody, you know what I'm talking about. So let's look at and quickly see how we deal with this. So now I have that, so I simplify this side, very simple, and I get 5 is equal to 25. I divide both sides by 25. 5 divided by 25 gives me 0,2, and 25A divided by 25 gives me A, and then I find A is 0,2 meters per second squared. Well, that was easy, right? We're going to do it now to see whether you can really do it yourself, whether you're pretending that you're so smart there. the teachers and supervisors, they make sure they get their pens and books out because we're going to do this one in a few minutes' time. Again, just to see if they're going to, I'll switch off the screen just to see whether they can really do it. And now, let's go back and do the last part of it. So now we have solved for A, but there were two unknowns. So all I do is I take 0,2 and I put it in there, and then I solve for T1. So let's do that. So let's quickly write down, substitute that one into number 4, and there we go. We've got T1 minus 196 equal to 20, and A is 0,2, and then I find if I multiply that, I get 4, and if I take that away, it's 196 plus 4, it means it's 196 plus 4, that is, and that gives me 200 newtons. And there I have solved for T1 by a simultaneous equation, which appears oh so often in the Newton questions in my question paper. You think you can do it? Well, maybe that is exactly what we must do. We must quickly work through that sum again. While we close the screen, we'll follow on the whiteboard to see if we can do it. Let's do it together. Everybody get their papers out, and let's start this while I'm quickly taking a sip of water here. All right. So what is it that we have to write? Here is my whiteboard. All the things that you need to see is almost ready for you. I'm going to use some color and some color just to highlight what I want to say. So we'll take this diagram first. And we'll do that for the 5 kilogram that side, and we'll do for the 20 kilogram on the other side. So what do? I say, well, F net is the sum of the forces, so I know upwards is positive, no problem, and downwards is negative, no problem. And I write that down, and I say upwards. I can just make a sign, upwards positive. That's all I have to write. I don't have to write a long sentence, so that whoever marks my work can see this exactly what I'm doing. So what do I write now? I say, well, T2, which is 250, I'm going to start right there. 250, I'm not going to make a long story. 250, and I know this one W is 5 times 9,8. Well, we know it's minus negative direction first, and M times G, that's 9,5 times 5, is 49. That we know already. And this one is unknown, minus T1. And how many forces do I have? 1, 2, 3. And look, each one comes with this direction. Huh? That one is positive direction, negative and negative. And that is, what is M in this case? How much is it? 5, that's right. So M is 5, and A is the unknown one. There we go. So that A is the unknown one. So what is the other one on the other side? Let me do again. F net is equal to MA. So F net is the sum of the forces. Well, how many forces do I have? 2 forces. That's right. That means T1 is an unknown one. Remember, T1 is unknown. T2 is known. And that is positive. And W is minus M times G. It's 20 times 9,8 is 196. So remember, and that is equal to 20A. Okay, and then I just mark it. I say that's number 1, and then that is number 2. Maybe I must use different colors just to do that. I'll say that is number 1, and that is equation number 2. Right, and now, what do I do now? How can I now eliminate the unknowns? I have an unknown T1, and I have an unknown A in this one, and I have an unknown T1 and an unknown A. I want to get rid of T1 first, so I'm going to rewrite that one underneath here. So how will I do it now? What will I do now first? I'll write the 196. I can get the T's underneath one. Right, minus 196, and it's plus T1 this time. Remember, T1 is plus. I'm just rearranging it to put my T's and so forth underneath each other, and that is equal to 28. So I have 28 there. Okay. So what do I do now once I have that? And I have them below one another, and now I'm going to eliminate T. How will I eliminate T? How will I eliminate T in this case? It should actually be number 2. I will add these two so that I get a 0 there. And then I'll add those two, and I'll add these numbers together. So, okay, so I will now draw a line. Unfortunately, I don't have my ruler here today, but let's try and draw a straight line like that. Okay, so what is that now? 250 minus 196, well, minus 49, around about 5. I think that's 5, if I remember correctly. So 5, if I add up all those numbers, did you see what I did? Simply added that to, subtracted that from that one, and that from that answer, and I got 5 is equal to, and I added this, and that is 25A. So I added 250 minus 49 and minus 196, and I got 5. And then, of course, divide both sides by 25, and then this becomes 0, 2, and now I remember my unit, and my unit for acceleration is meters per second squared, and that was the answer for A, and A is A. All right, and now I take that answer and I substitute it into 1. I substitute that into, so I substitute the A, substitute A, and what is A? To 0, 2. I substitute that into, let's say, equation 3 as I've numbered it, into equation 3. And how do I do that now? Very simple. I say minus 196 plus T1 is equal to 20A. And obviously, I take the 196 over, so I have T1 is 196 plus 20 and comma 2. Sorry, I'm running out of space there at the end, but you get the idea. And that is then 200 newtons. And there is the sum. Now, let me ask you, is that so difficult? No, you're obviously going to say, no, that is not so difficult. That is very easy. Now, let's get into the second part of it. Let me just show you. I will look again on my screen to see what that looks like. Look at it very carefully. Make sure that you actually understand it very carefully. Look at it again carefully. Talk to someone next to you about it, because if you don't talk about it, then you are going to have problems. Because the reason why you need to talk physics is that it makes sense to you. For instance, if I ask you where does the 49 come from, then you will tell me it's m times g. Where does the 196 come from? It is m times g, but it's downward, that's why it's negative. That's why it's negative. T is the unknown, downwards negative, but yet T is upwards positive for that one. And that is where some learners get caught in a trap. But, here's the surprise, all smart physics learners always have another way of doing the same sum. What, you say? Yes, I've just eliminated T, and then I solved for A, everybody will agree, and then when you solve for A, we then later put that A into the equation above, and we found T1. But what about this? What if we eliminate, let's say, A immediately, and then we find a T directly? What do you say? Let me explain to you quickly, and then you try and do it after me. Let's do it quickly, very quickly. Okay, here we go again. Let's say I'm going to use the same tools. What is that? My equation, F net is equal to MA. My very useful diagram. Do it, please, in the examination, even if the examiners don't ask for it. Do it for that one body and do it for the other body. Answer the one question they want you to answer, but on your question paper, you also draw that one for yourself somewhere to the side because you're going to need it. So let's go. So there we have it. So it's T2 minus T minus mg. You know where it comes from? T2 minus mg minus T1 is equal to 5a. T1 minus w, which is mg, is equal to 20a. You say, oh, how boring is this? And then you start substituting. T2 is 250. T1 is T1. M times g is that one, is equal to 5a. And hold it. I want to do the unimaginable. I want to multiply this equation by 4. Is there any smart learner out there who can look at the screen again and see why do I want to multiply this one equation by 4? Equation number 3. Have a look again and see whether you can send me an answer. Why on earth we want to do that? And I'm looking at the screen, but let me first look at this and see why on earth would I want to do that. That's why I put it in green. This equation has 20 A's. This one has 5 A's. Do you see that? If I multiply this by 4, how many is that going to come? 20. Oh, so I'm going to have 20 A's here and 20 A's there. And that, smart learners, is the clue of how to get equal to, how to get rid of A, how to eliminate A. Do you remember when I eliminated T, I had 1T positive and 1T negative. It was 1T, 1T. Now I want to make it 20A and 20A. Now I get the picture. Then I can solve it very easily. Let's look. Let's do this fast because you've got 3 minutes to do this. Okay, so I'm going to multiply that one. So it is 250 times 4 gives me 1,000. Minus T1 multiplied by 4 gives me minus 40. That was 96, I think it was. Yes, it was 96. Yes, that's right. 96 be multiplied by what again? Oh, and I'm multiplying by 4. No, it was 49. 49 multiplied by 4. That will give me 196. For a minute I thought something was very wrong there, and I couldn't place that very well. So it was 49, and I multiplied 5 times 9. That one gives me 49. Multiplied by 4 gave me 196. And I multiply that by 4, I get 20A. So there's my new equation with 20A and 20A. So let us quickly see, what do I want to do now? I want to eliminate A so I can solve directly for T. So how do I do this? Let me hear. Shout from there up to here in Cape Town, in Stellenbosch, where I am, and tell me, how do I do that? I've now got both equations in terms of 20A and 20A. So how do I get rid of the A? Any smart ones out there? I'm looking for answers, but no one sent me the answers here. They're all sitting there glued to the screen, I think. Let's do it, and then you're going to do it yourself again. So, put in the values. 20 times 9, I don't do anything here because 20 is 20. I wanted 20 the same. So I make the A's the same. The T's are not the same this time. So I make the A's the same. Okay, so there we have it. T1 minus 196 is 20A. So what do I do now? Again, I do like I did before. 2 equations with 2 unknowns. Write them below, one below the other. So I'm going to write that one over there. So T1 minus 196 is equal to 20A. So there I have those two, one below the other, 5 and 4, and I'm going to take that 20A and minus this 120, this 20A here. 20A from equation 5 minus 20A will give me 0 A's. That is smart. And then I have nothing. And 196 minus 196 will give me 0 as well. I'm going to do that slowly. So I'm going to write 1,000. Right? And I'm going to say, remember, I'm going to subtract now, minus 40, and then this one gets a minus because I'm subtracting, and then I add the 2, then I get minus 5t. So it's minus 4t minus t. There we go. Minus 4 minus another one gives me 5t. And 196 minus 196 is 196 plus 196. I add up, gives me 0. And 20A minus 20A, I add up and I get 0. So for T, 5T1 is equal to minus 1,000. Divide both sides by 5, minus 5, and what do I get? T is equal to 200 newtons. Wow! Is that smart? Or is that smart? Let's quickly do it, you and me together, and see whether you can actually beat me before I'm done. Remember, I'm old. You're much faster with your brain. So I'm going to do this one again. So it's 250 minus 49 That's right. That's now that we know that's already. Minus T1 is equal to 5A. Right. And what is the other one again? What is the other one again? That one, that side. So that one will be T1 minus 20 times 9,8 again. Please shout me the answer. 196, that's right, is equal to 20A. So what must I do with this one to get there? I multiply this one by how much? By 4. I multiply this one by 4 to get those two almost identical. So therefore, let me do it. So this one by 4 gives me 1,000 minus this by 4, 36, 196, that's right, 196, and that by 4 minus 41 is equal to 20A. Okay, and then I rewrite that below this, and I have T1 minus 196 is equal to, oh, that's a positive, of course, 20A. So my A's are the same. And I'm going to take this one, let's call it number 5, and this one, let's call this number 4. I'm going to do, what am I going to do now? I'm going to say number 5 minus number 4, equation number 4. So what do? I'm going to subtract. So this becomes that. This one becomes a negative now. And this one becomes negative. And now I add up. I add up now. Let's add up. So what do I have? 1,000 plus that much minus this much cancels. 4 minus, that's right, minus 5T1 is equal to that plus this one cancelled, and that answer is 0. So minus 5T1 is equal to minus 1,000, right? Divide this by minus 5 and that side by minus 5. And what does that give me now? It tells me that T1 is equal to 200 newtons. Oh, this seems to be a shorter way, but you must be able to work with your figures very, very well. Well, let me just look at and summarize for you the skills we've done today. I've got 3 minutes to go through it, and then I want to remind you about the main points, and then just wanting to remind you about do your chemistry and how you should be doing it. Let's quickly look at my write-up that I've done that you are supposed to have. There we go again. What are the main points? That one has 5A in it. This one has 20A. And then I multiply that one by 4 to get 20A in both cases. Then I change the signs of the bottom one. That becomes a minus T, so I have 5 minus T's. This one becomes a plus 196, and I add, I get 0. This one becomes a minus 20, and if I add them, I get 0. So minus 5T is 1,000, and T is equal to 200. You got that? Right. So the question remains, what are the skills that you are supposed to know? Here we go. The skill that you are supposed to know, when you write Newton to F net is equal to ma, it means one body, there's m, with many forces, so sometimes you get 3 forces. Just remember their direction. Second point, isolate body 1 by drawing a free body diagram. Isolate body 2 and write the equation. 3 forces, and there's the equation. F net is equal to ma. Do the same for the other side. Isolate body number 2, in this case 20 kilograms. You got it? And then you say 2 forces, so you must have 2 forces on the left, is equal to 20A because you're working with a 20 kilogram body. So there we go, 2 forces, 20A. And then you add it together. Because the signs are opposite, you now add it up. And if you find the T's will eliminate, and I can solve for A, etc., etc. Do you think you have that? Well, I've got nothing more to say to you, except if you look at the last part of the question, which says, which one of strings 2Q or P will break if I suddenly jerk this? And the answer, of course, is Q, simply because Q bears a heavier weight. It weighs the 5 and 20 kilogram, and the inertia there would be greater. So we have Q will be bearing 5 and 20, and P will only be bearing 20. So therefore, the tension in Q is larger than the tension in P. So Q will stretch and reach breaking point faster than anything else. Well, I hope that you had an enjoyable afternoon. Let me just quickly summarize in 1 minute for you. There we go. Let's see. Fnet is equal to MA. Don't forget to get your free body diagrams correct. It's important that you draw as many possible of them as you can. And when you study your work, please do your organic chemistry in this section, which is about an investigative question. And when are we meeting again? On Tuesday, the 24th of July, same time, same place, and then we'll be talking about reaction rate. Good afternoon, and keep well and work hard.